The last time we met, I told you we would get exercises for chapters 1, 2, and 3. So here are the solutions. The first question in the first section was write the 7-digit whole number which has a 7 in the 100 place, a 5 in the 10,000 place, a 3 in the million place, a 2 in the 10 place, a 5 in the 1 place. 0 is everywhere else, and my answer was 3,050,725. You can copy that down. 3,050,725. In problem 2, we wanted to write the number 3,050,725, 25 with a hyphen here. And in number 3, we wanted to insert a less than, greater than, or equal sign between 5,111 and 4,999. And the 5,000 is greater than the 4,000. We wanted to round 3,249 to the nearest hundred. Nearest hundred's the 2. Circle the 2, make all these 0. The first number you dropped is less than 5. Keep that as a 2. So 3,200. How about 3,250? You're exactly in the middle, so you're going to go up to the 3,300. And then you wanted to round 3,951 to the nearest hundreds. So you circle the 100 digit, you drop the 5 1, the 5 makes this 9 bumped up to the 10, so the 39 gets bumped up to a 40. You get 4,000. 59,000 is a result of rounding a 5-digit whole number to the nearest thousands. What is the smallest number that can be rounded to 59,000? Why don't we try? We want a number that is slightly smaller. Yeah, the smaller number. How about 58,499? That's just one less. Circle the 1,000 digit. You circle the 1,000 digit. The answer is no, because when you round, you could have rounded a smaller number. Okay. How about 58,600? No again. You can go smaller than that. How about 59,499? You want to circle the 8 and you get zeros here. That's 58,000. That's too small. So sooner or later you're going to come to the number 58,499. Okay, 500 did not work. 499. You want to round to the nearest thousand. You circle the 8. You make all these 4990. The first number you dropped was less than 5, so it stays at 58,000. We wanted to go to 59,000. So 58,500 is the smallest number that can round it to 59,000. Okay, I'll leave this up for a few seconds. You can read it. You can take notes if you'd like. Okay, then we go to the next section. We had an irregular hexagon, which is 6 sides, with the sides being 35, 92, 73, 52, 64, and 81. How much fencing do you need? Well, you add all of these numbers, and you're supposed to get 397. You should have done the math already. This is just as a check. Then Millie had $945 left in her checking account after paying $535. How much did she have originally? Well, the $945 plus the $535, which is $1,480. If you find a mistake or a misprint, please let me know. my email address is hfeiner, H-F-E-I-N-E-R, at coastline.edu. On Friday, you had this many teenagers attending a concert. On Saturday, you had 999 more. How many were there on Saturday? Add the two figures, you should get 3,391. The regular price of a suit is $417. It is marked down to $88. It's marked down $88, so $88 come off of this. How much do you have to pay? Well, you have the original 417, 4 and 1, 3 and 1, 4, 417 minus 88, which is supposed to be 329. Yes, no? The seating capacity of the Los Angeles Coliseum in 35 was 105,000, and a few years later it was 92,604. How many more seats were there in 76 and in 35? Well, you take the difference of the two, you do your subtraction, and it's supposed to be 12,396. So 12,396 seats more in 1935 than in 1976. Again, you should have done your work already, so you can just check your numbers. If the numbers are right, if we agree, fine. If we don't agree, who is wrong, you or me? And it could be me. In the Eiffel Tower problem, it is 1,063 feet tall. The Sky Tree in Tokyo is 2,080 feet tall. How much taller is the Tokyo Sky Tree than the Eiffel Tower? You subtract the two numbers, and you're supposed to get 1,017. Okay. Now, you go grocery shopping, you buy items for $4.73, $3.79, $9.05, $12.99, $6.17. You have $40 in your wallet. Do you have enough money to pay for this? Well, you add, you do an approximation. This is about $5, this is about $4, $9, $13, $6. The sum is supposed to be 37. If it's 37, you have enough in your account, in your wallet. And I don't know where this came from. This came from somewhere else. So we are done. Ignore this very last line. I think this was left over from a similar solution that I had done earlier. Okay. Then for the third section, the exercises were as follows. An agricultural corporation has 217 rows of orange trees. Each row consists of 99 orange trees. How many orange trees are there? You multiply 217 by 99 and you're supposed to get 21,483. You go ahead, check your numbers. I'll leave this out for a little while. So apparently the corporation has 21,483 trees. There's a way of casting out nines which they don't teach anymore, so if you're interested, send me an email, I can show you how to do it. Don't use a calculator to do this, okay? Be careful, no calculator. Why? Because once you get used to a calculator, it's very difficult to do problems like that. And you should be able to do problems quickly. Make sure you know your multiplication table. This is another joke. In the second exercise, A hamburger costs $7. A fish dish costs $18. What is the total cost of 12 hamburgers and 5 fish? 12 hamburgers times 7, 5 fish dinners times 18, 84 and 84 and 90. If you add the two, you're supposed to get $174. Did you get it from $174? I can't hear you. Okay, you did. Good. Good for you. The dimensions of a swimming pool are given. A concrete walk of 5 feet surrounds it. What is the area? Well, I said you can choose your numbers. Whatever you put down your length plus 5 and 5, 10. Put down your width plus 5 and 5. And from that total, when you multiply, you subtract the numbers that you have inside. Okay. I meant to give you numbers here, but apparently I didn't. Maybe I did in my solution. Yeah, I guess, no, I didn't. Now, I want you to find the area of the following. Here is what I gave you. Here's what I was supposed to have given you. 23 feet this way, 12 feet this way, 30 feet this way, 20 feet that way, 7 feet this way, and 8 feet this way. You want to put a concrete walk. I broke up the concrete walk into different sections. You multiply the area of the sections, like this rectangle here is 20 feet by whatever this dimension was. Oh, that's 5 feet. I want a 5 foot concrete walk. So you get 40 times 5. In area B, you get 25 times 5. In area C, which is this rectangle, you have 60, and so on and so on. And the total is supposed to be 600 square feet. And then I have the product of this and 10,000. All you have to do is add 3 zeros to the right. So you get 7,290,000. And that's about it. So we'll take a little break and I'll come back. We continue with chapter 4 in my book, which is really division of whole numbers, section 1.4 in your textbook. Every chapter is a section in somebody's book, specifically arts. That's what I built it on. And if you want to send me a message, hfeiner@coastline.edu, and you can request the PDF. If this is not available to you in print yet, I can send you the whole book for free on the internet as an attachment to an email. And we proceed with dividing whole numbers. We will also do section 1.5, exponents, order of operations, and averages. And section 1.6, more on solving word problems. Yeah, word problems. Oh, you love word problems, don't you? Now we go to the basics of division. If we think of multiplication as repeated addition, remember that? 2 times 3 is 3 plus 3, or 2 plus 2 plus 2. Then let's think of division as repeated subtraction. Divide 12 by 3. 12 is called the dividend. 3 is the divisor, and we get 4, which is the quotient. Quotient, with no number left over, so no remainder. I can subtract 3 once, I get 9. I can subtract 3 a second time, I get 6. I can subtract 3 a third time, I get 3. A fourth time, I get 0. I cannot continue subtracting. I have nothing left to subtract from, so I stop. So I was able to do that 4 times. Now I want to divide 1,000 by 13. How many times can I subtract 13 from 1,000? Well, it looks like I can subtract it 1,300 times, I guess. We'll see. How many times can you subtract from tens? Just think of 13 as the close. So I'm interested in dividing 1,000 by 13. they teach you how often does it go into 1, it doesn't, into 10 it doesn't, into 100 it goes probably something like 7, 8 times. Try 7, if it works great, if not you can change it. And again, make sure you know your multiplication table. Okay, I'm telling you what I'm about to do. So you are writing 1000 here, you're dividing by 13, you have your V-shaped line. Again, how often does 13 go into 1? It doesn't. In 10, it doesn't. In 107, write the 7 above the 0. And make sure you have nice vertical columns, spread apart, not bunched together. So you subtract 91, that gives you 9. You're finished with the tens. You add the ones. You have 0 ones to be added. How often can you subtract 13 from 90? A little bit less than 7, so 6 times. So my answer is 7, 8, 78. And you have 12 left over. All right. I do more, I tell you, the basics. So if you wanted to check, you could multiply 13 by 76 and add the remainder, which I said was 12, and that should give you 1000. Would you like to take notes here? So you're dividing 1000 by 13. 13 does not go until you have 100, which is really 1000. We are not working with the ones yet. You write the 7, you subtract, you get a 9. You bring down the next digit, which is a 0. How often does 13 go into 96 times? That gives you 78, and you're left with a 12. 12 is your remainder. Can I go on? All right, thank you. Divide 26,910 by 13. Again, I give you some hints here. The real part is here. We wanted to divide 26,910 by 13. How often does 13 go into 2? It doesn't. Into 26 it goes twice. We have not touched these 3 positions yet, so we're working with 1,000. We'll bring these other positions later on. So you get 13, which is really 13,000, which you subtract, you left nothing here. We bring down the 100, which we haven't done yet. Yeah. And that gives you a 9. How often can you subtract 9 from 13? That many times. That 0 is crucial. Make sure you put a number here. The number is 0. And you continue. You bring down the 91, which I should have right here. We are here now. I copied what I had previously, so you don't have to go and erase something that you've written already. So we had the 91. We can subtract that. 7 times 13 is 91. We subtract 91, we are left with 0. But I have not touched the ones yet. We're finished with the tens. I have one more 0 to bring down. And how often can I subtract 13 from 0? 0 times. That 0 goes in this position. Don't ignore the 0. You must have a number above every number in your dividend. So that is the 0 right here. So how often can you divide 13 into 26,910? 2,070 times. Again, watch out for these zeros. They are very, very important. They are crucial. You need time to copy this. This is essentially the final result. If you multiply the 13 by 2070, you're supposed to get 26,910, and apparently you do. All right. You want to divide 0 by 5. How often can you subtract 5 from 0? Not at all. Not even once. So 0 divided by 5 is 0. Okay. If I write this as a fraction, which I will do later, I will have 0 over 5. But be careful. How often can you divide 7 by 0? How often can you subtract 0 from 7? You can do it once, you still have 7. You can do it a second time, a third time, a fourth time. No matter how often you subtract 0, you're left with 7. You can keep on going more and more and more. So how many times can you do it? I don't know. There is no such number. If you think you can do it only 1,000 times, I can do it 1 more times than 1,000. So the number of times you can divide or you can subtract 0 from 7 or divide 0 into 7 is undefined. The number of times you can divide 7, you can divide yeah, that was a division. So the number of times you can do this is undefined. That keeps on going and going and going. Okay? So division by 0 is undefined. Don't say 0 is undefined, because if you get a 0 on the test, you may wish it were undefined. Yeah, you can laugh. You may wish you were undefined, but it isn't. So 0 is not the undefined. The division by 0 is undefined. You cannot divide by 0. Another way I can remember this, instead of subtraction, write 12 divided by 3 is 4. Multiply the 3 by 4, that should give you the 12. Multiply the 3 by 4, that should give you the 12. Divide 5 by 0. There's a number here. When you multiply these two numbers, you must get 0. So that has to be a 0. How about this one? 7 divided by 0 is some quantity. When you multiply the 0 by that quantity, you're supposed to get 7. But 0 times any number is always 0. So you can never get 7, which is equal to 0. So that process is undefined. Again, division by 0 is undefined. Then we want to go to the properties of of division. There is no identity for division. Although n divided by 1 is n, the commutativity of that does not work. 7 over 1 is 7, but 1 over 7 is not 7. So there's no identity for division. What was the identity for multiplication again? 5 times a number is 5, or a number times 5 is 5. Yeah, 1. 5 times 1 is 5, and 1 times 5 is 5. You can commute. Division commutativity. The 16 and the 2 cannot be interchanged. 16 divided by 2 is 8, but 2 over 16 is not 8. We'll see later it is 1 over 8. A over B. A divided by B is not the same as B divided by A. Division also is not associative. If you associate the 8 with the 16 or the 8 with the 2, this gives you a 2. 2 divided by 2 is 1. You divide the 8 by the 2, that gives you 4. 16 divided by 4 is 4. 1 is not equal to 4. You want to take that down maybe? If you had the PDF here, it would be a lot simpler. You can just follow what I have. You can take notes if you'd like. So A divided by B and then by C is not the same as B divided by C, and then that divides A. Now there are some numbers for which this works, but in general it does not work. So does it work in every case for all the numbers you can think of? No. Careful about the non-existent distributive property of division. Remember I said I want you to remember distributive property of multiplication over addition and or subtraction, not multiplication over multiplication. Okay. This is something you should not do. 24 divided by 4 plus 2 is not 24 divided by 4 and then plus 24 divided by 2. On one side you get 4, on the other side you get 18. So be careful when you have a sum in the when you have a sum as a divisor. Later on I'm going to write this as a fraction. I'll have 24 in the numerator, a bar, and then 4 plus 2 in the denominator. Can I go on? Okay. Another example. Now instead, be careful here that you don't associate these two, you don't get the same result. This is incorrect. Do not go wrong here. I think I just said that. I don't know why I'm tracking back. Now, division on the right of parentheses, that's another story. You can, I hesitate to say distribute, because if I distribute over there, it doesn't work. If I distribute here, it does work. So it depends whether I have the 16 plus 8 in the dividend or in the divisor. In the divisor, it does not work. In the dividend, it does work. For instance, 16 divided by 4, to which I add 8 divided by 4, gives me the same as 24 here divided by 4, which is 6, or 16 over 4, which is 4, plus 2, which is also 6. I would stay away from distributing division over additional subtraction. Okay. I wouldn't do that. And in this case, nobody in his right mind would do it this way. When you see that you can add two numbers, add the two numbers. You get 24 divided by 4, your result is 6 immediately. I just did that for an illustration, just to make a point. A whole number ends, if a whole number ends at 0, you can divide it by 10, and that is simply by eliminating the 0 on the right. For instance, if you had 210 and you subtracted 21 10 times, that would leave you with 21. So if you divide 210 by 10, it's like crossing out the 0. Some examples. Your budget of $2,627 allows you to take city children to a camp for 3 days. Now, isn't that nice? The cost per child per day is $57. How many children can you take? Well, now the cost per child for 3 days would be 3 times 57, or 175 days. This is multiplication, because for the 3 days you had 57 for the first day, plus 57 for the second, plus 57 for the third. This addition tells you that you need to multiply. Now you need to divide your original budget of $2,627 by 171, because you start out with this number. You subtract 171 for the first child, that was 171 for the first child. From whatever you're left, you subtract 175 for the second child. You can keep on subtracting until you're down to no dollars, or not enough dollars here. And what is repeated subtraction? Division. So first we have to multiply, now we have to divide. How often can I divide 2,627 by 171? Does 171 go into 2? No. Does it go into 26? No. Does it go into 262? Yes. How many times? Once. Subtract 1 times 171 from 262 and get 9. Take down the next, you get 91. You're done with that part. You have not worked with the ones yet, so take down the 7. Multiply 171 by 5. You do a subtraction again. 5 times 171 is supposed to be 857, and you're left with $62. And is that enough? No. You're left with $62. That's not enough to get another child for 3 days. So how many children could you take? 15 children. And that's about it. I'll let you copy this if you'd like. We take a few minutes here. How are you enjoying this so far? Oh, I'm so glad you said you enjoy it. Makes me feel real good. Okay. A company budgets $8,400 for a party to 35 senior staff members. How much on the average is budgeted for each one of these individually? Okay. You have to divide this into 35 parts, which means you do a division. How often does 35 go into 8? It doesn't. Into 84 it goes. 2 times 35 is 70. Subtract 70, you're left with 14. You haven't worked with the tens yet. Working with the tens, take down the next digit, which is 0. Yeah, 0. How often can you subtract 35 from 140? 4 times. Okay, that gives you 140 exactly. You need a digit here. That's a 0. You cannot subtract anymore. So how much could you have spent on the average for each of your staff members? $240. $240. You want to copy this if you don't have it already? Hey you, don't fall asleep. Oh, come on in. So $240. Example 3. A farmer budgets $1,000 to put a fence around a square plot of land along a river. There is no fencing along the river. How much fencing does he need to purchase? If fencing costs $48 for every 6 feet of fencing, what are the dimensions of the largest plot of land that can be fenced in with your budget? Well, the cost per foot, I know how much it costs for 6 feet. Per foot, I divide 6 into 48, that's $8 per foot. The number of feet that can be purchased is 1,000 divided by 8, which is 125. You can do a division and see. And we divide this by 3 sides. We don't want to put a fence where the river is. And we want a square. So we have all the 4 sides are the same dimension. So 125 divided by 3, because there are 3 sides, is 41. And there's a remainder. But we can't use the remainder. We can't use 1 foot or 2 feet of fencing. So that's 41. So your plot can be 41 by 41. You fence 3 sides. 3 times 41 is 122. So you're left with 2 feet of fence that you can't use. Then I am ready for the exercises. You want to look at this a little bit more? I'll give you a few exercises and we'll go over the solution next time. Make sure you do this as part of your homework. It will help your understanding. I seem to be drifting out of the picture a lot. You don't want to look at me? Don't answer that. Okay, exercises. Your budget of $5,697 allows you to take city children to a camp for 4 days. The cost per child per day is $86. How many children can you take? So you have $5,697 for 4 days, and each child per 1 day costs $86. So how many children can you take? A company budgets $9,477 for a party to its 27 senior staff. How much average is that per staff? $9,477, 27 staff, 27 people. A farmer budgets $3,000 to put a fence around a square plot of land along a river. There's no fencing along the river. Fencing costs $54 for 6 feet. What is the average dimension of the largest plot of land that can be fenced in with this budget? So $3,000, 3 sides need to be fencing. Fencing costs $50 for every 6 feet. And what's the largest square that you can surround, fence, with your budget of $3,000? Then, I got a good one for you. Pick a number between 2 and 10. 3, 4, 5, whichever you'd like. It works for bigger numbers, but I don't want you to get involved with too many big numbers. So pick a number between 2 and 10. Let y be the sum of your chosen number from here and 2. So you need to know what sum is. If you take the sum of your number and 2, you have the number y. Use that number y now that you found previously to find z, where z is the product of your number y times the same number y. So y times, I already gave it away. So this is like y squared. You got your number z now, you use it. The u is the difference of your z and 4 times the number that you chose up here. So be careful if you understand what difference means. And then finally, you want to use the number u in order to find the number v, which is a quotient of u and, oh, what am I missing? Oh no. V is a quotient of u. I am missing something. Oh, that's terrible. I should have caught it. V is a quotient of u and yeah. And then you should come back with the number that you chose originally. Let me see if I can find that quickly. I don't want you to see all this. Yeah, you divide by your chosen number, I think. So see if this works. V is the quotient of u and your chosen number. I think that's what it is. Try it and see. Okay. We'll take a little break. 1 minute or so. We'll go to the next chapter, my chapter, your section, section 1.5, exponents and order of operations. Order of operations is going to be very, very important. Okay? So we do exponents, chapter 5, exponents, order of operations, and averages. What is 2 times 2 times 2 and so on? Oh, do you get a headache looking at all this? Isn't that awful? Do you think there's a better way of writing this product? As a matter of fact, there is. You have 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 2's. Why don't we write this as 2 raised to the power 11? A regular 2 at the main line, and a little 11 in the upper right-hand corner. This has to be smaller than the 2. This means 2 raised to the power 11, or simply 2 to the 11th power. And it means 11 2's multiplied together. How do you get this number? Well, you can associate 2 times 2 times 2, which is 4 times 4 times 4 up to here, and you have an extra 2 left. And then you have 4 times 4 is 16, 4 times 4 is 16, 4 times 2, 8. These 216 times 16 is 256, times 8, 2042. That's one way of doing it. That's not the way most students would have done it. Most students would have said 2 times 2 is 4, times 2 is 8, times 2 is 16, and each time you get 1 less. 32 times 4, you have 1 less here, and so on, until you are left with only 1 2 and that gives you 1024 times 2, or 2048. So which do you prefer? The way most students would do it, or using the associative property right here, associative property of multiplication? Which is simpler? You decide. You need time to copy that. I'll give you a few seconds. We've been at this for 3/4 of an hour now. Powers come in handy when setting up the decimal system. 1,000,000 was 10 to the power 6. 10 times 10 times 10 times 10 times 10 times 10. And then 100 is 10 to the power 5, 1 less 6. 10 to the power 4, 10 to the power 3, 10 to the power 2, 10 to the power 1, 10 to the power 0. Ooh, 10 to the power 0, that is 1. Isn't that amazing? 10 to the 1 is 1. That's not surprising. But 10 to the 0 is equal to 1? Wow! Would you have guessed that? 10 to the power 0 is 1? Lots of students think that you have to multiply these two and this is 0. It is not. I will show you later that any number to the power 0 except 0 itself is 1. Some authors use the following scheme. You have 2 to the 4, which is 16. On the left, you subtract 1 from the exponent each time. And on the right, you divide by 2 each time. So when you divide by 2, you get 16, 8, 4, 2, 1. And when you take 1 from the exponent, you get 4, 3, 2, 1, 0. 2 to the 0 is 1. What is the square of 3? 3 times 3 is 9. This is 3 times 3. It is not 3 times 2. So that 2 has to be written much smaller and in the upper right-hand corner of the 3. The 3 is called the base. The 2 is called the exponents. And 3 times 3, 2 3's multiplied together. Not 3 times 2. 2 3's multiplied together. 3 times 3. Is 9. 3 to the power 3 is 3 times 3, which is 9, times 3, which is 27. Okay? So that's for exponents. And then we get into something very crucial, the order of operations. But then almost anything we do here is crucial. This is just a little bit more crucial than the average crucial. Why do we need the order of operations? Well, let's take a look. Suppose you perform a job and get paid for your fixed cost of $25. Fixed cost, you arrive there, you sign in, you get $25. And for each hour that you work, you get $20, and you work for 12 hours. So you should be getting 25 plus 12 times 20. And this is supposed to be, so you request $320, namely 240 plus 25. That doesn't look like that. It looks more like it would be 265. So let's see what's happening. You are requesting $320 because somehow you figured this was $320. And your employer just sends you a check for $265. Can you go back to your employer screaming, hey, you owe me some money? Oh, that's an unfortunate situation. How did you get 320? I guess you added the 25 to the 12, that gave you 37, and 37 times 20 apparently is something like that. But anyway, somehow you get a number here like that. And there's a discrepancy. So mathematicians found a way to make sure that we always get the same number, all of us. We use an acronym PAMDAS, P for please, excuse my Please, P, excuse my dear Aunt Sally. Please excuse my dear Aunt Sally. Now, this is nice to remember. The first thing we do is look for the innermost group, parentheses. If you have lots of groups, lots of parentheses and so on, and numbers in the parentheses, with operations, addition, subtraction, and so on, you look for the innermost group. We say parentheses, but it's not always parentheses. It could be everything in the numerator, everything in the denominator, everything between absolute value bars, everything under a square root. So all that qualifies for a P. In that innermost P, do you have any exponents, like 2 cubed? If yes, replace 2 cubed by 8. No more exponents. Look for multiplication and division at the same time. Well, which do you do first, multiplication or division? It depends. You go from left to right, and the first time you hit one of these two, you do it. If it's a multiplication, you multiply. If it's a division, you divide. So it's not multiplication before division. Whichever occurs first is done first. Same for addition. Whichever occurs first of these two is done first. Do not take shortcuts at the beginning until you're absolutely sure you know what you're doing. Okay? Then you can take shortcuts. So my advice is learn this the proper way. Do not take shortcuts. I know some of you are not going to follow my instructions, but sooner or later you will regret that. So I tell you what this stands for, and I guess I tell you how the person got this here. No, maybe not. So this is your expression. There's no set parentheses to hold something back, so all of this is your P. Are there any exponents? No. Any multiplication or divisions? Yes. What is 12 times 20? It's 240. Plus 25, which is 265. Okay, 265. So 265 is right. And when you went screaming, you want $320, your employer said, you're wrong. That's the way we do it. That's the way we should all do it. Some examples. Ooh, what is this? Do you see any innermost P's? Yeah, here's the innermost set of parentheses. It has numbers and an operation. And in there, this is my P. I would copy all of this until parentheses, leave a space here, close parentheses, power 7, and then minus 10, minus 5, minus 1. And then in the innermost set of parentheses, I would get rid of the exponents, 9 minus 8. And then copy all this again till I'm here, leave a space, the 7 is needed, and so on. You no longer have any multiplication or divisions. Addition or subtraction, the first one from left to right is a subtraction. You subtract, you get a 1. Then you copy all of this. You're down to one number. And what is your innermost P now? The group that starts with brackets to the end of brackets. All of this is your next P. And the exponents, yes. 2 to the 6 is 64. 2 to the 4 is 16. 2 to the 3 is 8. 1 to the 7 is 7. Minus 10, minus 5, minus 1. Why don't I let you copy this right in up to, let's say, this point? So copy everything except what you're working with, work on that until you're down to one number, and then go to your next group. Let me know when you're done. I'm still here. Isn't math wonderful? Boy, whoever came up with all of these things, and it's not one person. This is knowledge of thousands of years, thousands and thousands of years. and many different civilizations. And we still keep on adding new things in math. Can I go on? So we are down to this group now. Are there any exponents? Yes, I just went over that. So no more exponents. Any multiplication or divisions? Here's the first one, it's a division. So I have to do 64 over 16, which is 4. I haven't done the multiplication yet. Here's a multiplication, I can do it, that's just 7. Copy everything else. Any more multiplications? Yes, there's multiplication here, do it, that's 32. There's multiplication here, that's just a 7, so 32 plus 7 and so on. No more multiplication or divisions in the brackets. Any addition or subtractions? The first one is an addition, that becomes 39. Copy the rest. The next one is a subtraction, subtract, that's 29, copy what's left. The next one is a subtraction, that's 24. The last one is a subtraction, that's 23. You're down to one number here. You start over again. You have a P. All of this is your P. Do you have any exponents? I don't see any. Do you have any multiplication or division from left to right? That's a multiplication. So you have to multiply 6 by 23 in order to get 138. And then as a last step, you add the 5, 143. Do you know how many people would get the wrong answer here? About 1 out of 10. I'll let you copy this and then I'll tell you something. Oh, I have about half an hour left. Most people would go wrong here. The first thing they do is 5 plus 6 is 11. Not here. And then multiplication comes before division. They multiply first. Not here. And then 5 minus 1 is 4. Not here. You subtract the 5, you subtract the 1, you subtract 6. And some people would say that 1 to the power 7 is 7. No, it isn't. It's 1 times 1 times 1 times 1 times 1 times 1 times 1. Okay. And some people would say that this is 2 times 3, 6. No. So be careful. If you got the right answer here, you are very good. Congratulations. My hat is off to you. Okay, I give you more of what I just said. And, oh, I want the exercises now. Oh, these are exercises. That was exercise, that was an example. Here's another example. You see if you can do it. You need time to copy it. This is example 2. That's exactly what I did. Okay, here I tell you where most people go wrong. I just went over that. And then we want to talk about averages. Averages, so n would be 7. So the sum of 7 numbers, what does sum mean? You add them. Divided by how many numbers you've added, by n. You add 7 numbers, you divide by 7. You add these 1, 2, 3, 4, 5 numbers, you get 35, you divide by 5, your average is 7. So you add 1, 2, 3, 6, 23, you get. I am back in chapter 6 in my book about word problems, and it also says word problems in Axt section. Word problems, also known as application problems, are the basis for solving practical applications. The mathematics, tricks, and procedures you learn in a class simply gives you the tools to combine ingenuity and logic to find a solution. You are working for an employer. You are expected to develop your own reasoning. You will most likely not be given an equation that needs solving, like we do here. We give you an equation, find a solution. Where did the equation come from? Well, you are given certain conditions and you need to dig out the equation before you can solve it. That's what a word problem or an application problem is about. Most authors suggest that you read the word problem until you understand it. I suggest that you don't do that. I suggest that you look towards the end where it tells you find such and such a number, and you give it a symbol. Let's say you know what it is. It's locked in a box. You give a symbol to the box. Your object is to open the box and find what's inside that number. So I am looking at the end. I'm finding out what is wanted. And I define what I want by a box symbol. Now I know you don't have a box symbol on your keyboard, so we'll have to get around that. Then I read the problem, and I use that symbol, that number that is locked there, mathematically or symbolically in all the details that I am given. And once I have a symbol for everything that is in the word problem, I look, I can usually see what to connect, how to build the equation, and then I'm home free. I can solve the equation. Okay. That's what I'm telling you in print. Examples. You plan a trip by car from Los Angeles to San Francisco in 3 stages. Stage 1, you go from Los Angeles to San Luis Obispo, which is about 200 miles and 5 hours. That's your plan. Then you go from San Luis Obispo to Monterrey, which is about 135 miles, and you think it's going to take you 3 hours. And in stage 3, you go from Monterrey to San Francisco, and you forget how many miles and how many hours. But you remember that the whole trip was 450 miles. So you are interested how many miles were in the 3rd stage. All right, I know the answer. The answer is in a box. And I call that the preamble. Where am I here? The previous problem? This is where I want to be. Okay. So this is the distance from Monterrey to San Francisco. Okay? It's locked in that box. The total trip was the 200 miles for the first stage, the 135 for the second stage, this many miles for the 3rd stage, which is combine these 235 plus that. That's the total number of miles, and the total number of miles is 450. Total number of miles equals total number of miles, written in 2 different ways. Total number of miles this way, and total number of miles this way. You have an equation, you subtract 335 from both sides, and you're left with 115. So the 3rd stage was about 115 miles. You had to dig that out from what was given there. You had to dig out the equation. And most people are going to make this X rather than a box with a question mark in it. And about how long would it take you? Well, what was your average speed? 5 hours for 200 miles, 40 miles per hour. 3 hours for 135 miles, 35 miles per hour. Going by this figure, you estimate that for 135 miles, it's a little bit more than 135 miles. You need a little bit more time. So a little bit more than 3 hours, maybe 3.5 units or something. You have to estimate this. No way of finding exactly. So if this makes sense, I go to the next case. Yeah, we are doing word problems now. I have about 20 minutes left, so I don't have to go too fast. Excuse me. In the second part, the second word problem, example, We have a rectangular area, plot of land, all of this, the total area is 2,400. And it is supposed to be partitioned in such a way that I have a square here. So x by x. That's the number in the box with the question mark. I call it x. And the total length I know is 120 feet. And what is the width? I don't know the width. But I want to find how I can make the square. So I wish I knew I had the width here. I have the base, I don't have the width. I have the area of all of this. So if I know the area of all of this and I know the length, can't I find the width? Isn't length times width area? Isn't 120 times this x over here is also the x over here? Isn't 120 times x 2,400? Well, if that is true, I think I can find x. Get it? You need the width, you have the total area, you have the length, you don't have the width. The width is x. So 120 times x is 2,400, or 2,400 divided by 120 is 20 feet. So you are going to make a square that is 20 by 20 feet. You put your partition in 20 feet from the start, from the left side of the rectangle. Is it true that 120 times 20 is 2,400? Yes. So I guess we must have done it correctly. A third example. Bob is twice as old as Amy. The sum of their ages is 36 years. How old is Amy? Would you like to take a shot? Would you like to try this? See if you can get it? What's the first thing I said you should do? Oh, you know the answer to what you are looking for. You know the answer to what you're looking for. Wow. How can I do this? I know the answer. What am I looking for? How old is Amy? And don't find it by guessing. You may be able to get the answer by reasoning, but that's not the point here. The point is to develop reasoning, mathematical reasoning, algebraic reasoning. So you use a variable, how old is Amy? You know the answer is x. I know the answer to every word problem, and so do you. Bob is twice as old as Amy. If Amy was 2 years old, then Bob would be twice as old. 2 times 2, 4. If Amy was 5 years old, he would be 2 times 5 years old. If Amy was 20 years old, he would be twice that, or 40 years old. If Amy is x years old, he is twice as old, 2x. So the age for Amy is x, the age for Bob is 2x. The sum of their ages is, what does sum mean? You're right, sum is addition. So x plus 2x makes 3x, and 3x must be 36. Okay? You have a number in the box, you have twice the number in the box. The sum of the two is 2 boxes plus a box which is 3 boxes. And sum of ages is sum of ages. Sum of ages written one way is 3 times the question mark on the box, or 3 times x if you use x instead of a box. And it's also 36. The sum of their ages is 36. So if 3 times a number is 36, you can divide both sides by 3. 3 over 3 is 1. 1 times this number is just 1. We'll get into this detail a little later. This may be a little bit advanced, but shouldn't be too much. So when you divide both sides by 3, you get 12. Check yourselves. If Amy is 12 years old, how old is Bob? What was it again? 2 times 2 times Amy's age, 2 times Amy's age, so 24. And is 24 plus 12 equal to 36? Yes, it is. So Amy is 12 years old. Are you ready for the next one, or do you want to copy something here? We have about 15 minutes left. Now, in the next one, what is going to change? Up there, Bob was twice as old as Amy. Bob is still twice as old as Amy in the next example. But up there, the sum of their ages was 36. Now I'm saying twice the sum of their ages is 36. Can you find Amy's age? Be careful with the word twice the sum. It's not twice the number, it's twice the sum. Go get it. You have somebody to work with, go ahead. If somebody else wants to help you get it correctly. What's my first step? Oh, I know the answer. What do I want? How old is Amy? I know the answer. Symbolically, in a box. A locked box, so I don't know what's inside. But the answer is in a box, so the answer is X. What do I know about Amy and Bob? Well, the same as earlier. Bob is twice as old as Amy. You should be able to get that properly. And twice the sum of their ages is 36. So what is twice the sum of their ages? This was x, this was 2x. The sum of their ages is x plus 2x, so the sum is 3x. I wanted twice that number, so I wanted twice 3x, which is now equal to 36 also. Let x be Amy's age, then Bob's age is 2 times that number, whatever that number is, it's 2 times that number in the box. The sum of their ages is Bob's age, 2 boxes, plus Amy's age, 1 box, a total of 3 boxes. Twice the sum. All of this is the sum. Okay, all of this is the sum. All of this. So all of this is multiplied by 2. Twice the sum. First you get the sum and then you multiply by 2. You don't multiply the first box by 2 and then add the second. And that is equal to 6 times what number? That's still part of working up symbols. And then I go to my equation. Twice the sum of the ages is twice the sum of the ages. Twice the sum of the ages, I worked it out already. I have that 6 times the number in the box. And I was told it's also 36. So this is 6 times too large. If I divide both sides by 6, I get 6. And 6 times 6 is 36. And then I should write the answers in a separate statement. Or what did I want? I wanted, how old is Amy? Well, Amy is 6 years old. I should write that as a statement for the answer of this particular problem. Thus, Amy is 6 years old. We have a number 5. Did you notice that all the examples I give you are reproduced, mostly reproduced in the exercises? So if you can do the examples, you should be able to do the exercises. And then later I show you the solution to the exercises next week, next video, video number 3. Just like today, I showed you the answers and the procedure to the exercises in video 1. section 1.1, 1.2, 1.3 in your author's book, chapters 1, 2, and 3 in my book. So let's attack this one. A charter school has 210 students enrolled initially. Every year they add 10 students, so they get 10 students more every year. Never mind how many graduate or how many withdraw, it is exactly 10 more than what they had in the previous year. What will the enrollment be after 7 years? What can I do here? I could say, what is enrollment after 7 years? It is X, but where would I go from there? The number of students after that many years is indeed X. The number of students added, they add 10 every year, 7 years, they add 70. And I think I'm ready for my equation. So what's enrollment after 7 years? The number of students originally, which was 210, plus the number that they added in 7 years, which is 70, and that number is 280. So the number I'm looking for is 210 plus 70, or 280. There wasn't really too much to do mathematically here. You just have the symbol, you don't do anything with that symbol, you just add 210 to 70. So this is more digging out what to do rather than doing it mathematically or algebraically. But I hope that was a decent problem. And then I am ready for the exercises. The Nile River in Egypt is 6 times as long as a White River in the United States. You can look up where the White River is. The sum of their length is 4,900 miles. What is the length of the Nile? So you have a Nile that is very long. It's 6 times as long as a White River. The White River is a lot shorter than the Nile. And if you add how many miles the Nile is to the number of miles for the White River, the total is 4,900. Can you dig that out? What's the first thing you should do? Then you're given a rectangle, and instead of partitioning it into one region, you partition it into 2. Okay? And the total area before you partition, without the partitioning, is 1,950 square feet, and the length is 130. How much is the width? And you remember how we did that earlier? You need to know what is the area of a rectangle, and I trust you remember that it is length times width, or base times height. Then Ray is 3 times as old as Sal, and the sum of their ages is 52. How old is Sal? That sounds like a familiar problem. Remember, you know the answer. You know how old Sal is. Good old Sal. How old are you? I imagine the number is less than 52. It has to be. How much less? Well, I'll tell you next week. Ray is 3 times as old as Sal. That should be a 3, that's an H. 3 times the sum of their ages is 156. How old is Sal? So Ray is 3 times as old as Sal. And 3 times the sum of their ages is 156. How old is Sal? Would you like to take a couple of minutes to try and figure that out? I'll give you about 2 minutes. would you do me a favor and let me know how you're doing with the video? This is only the second video. It may be a little premature to form an opinion, but let me know anyway. This is a supplement and a complement. It's not in place of the textbook. I hope this will help you. I hope this will help stimulate your thinking. Okay, I said 2 minutes. I wish I had some music to entertain you. I trust you're not hungry, because this is food, food for thought. Got you? Food for thought. The more you do of this, the less you have to eat physically. So that's a way of losing weight. You don't need to go to Weight Watchers. Just do a lot of math. Okay, are we ready for the next one? The next exercise, the last exercise? A gym has 1,500 members now. Every month, 25 members are expected to cancel their membership. And assuming that the more members come in, that is combined with the members that leave. So the number that leave versus the number that comes in, it's what is left after you deduct the number that left from the number that come in. So every month that number is 21. It happens to be the same number every month. And what will be the membership after 1 year? Again, you can reason it out, but try to do it with a symbol. Try to do it with X. Try to do it with the number in a box. Again, the idea is not to get the answer. The number is to develop a technique to get the answer. An algebraic technique. This is pre-algebra, but it's not too early to get thinking along these lines. So don't take a shortcut and just reason it out and you get the right answer. So I know the answer here. We have so many members now. Every month we are losing 21 members after 1 year. How does year figure in here? What's a year? It has 366 days. It has 52 weeks. It has how many months? Gee, I forgot. What else can I do in years now? If I divide the year, I could go to days. I did that. I could go to hours. How many hours in the year? How many minutes? How many seconds? Do I need all that? Probably not. So what could come in handy here? Oh, the number of months per year. How many months are in the year? Yeah. Every month we lose 21 members. We lose 21 members. That's a key to what the operation is that you need to do. Addition, subtraction, multiplication, or division. Okay? So I let you go here. I'm sorry you're going to miss me for about a week, but unfortunately I can't be on all the time. So enjoy what we are doing here. I'll see you next week with video 3. You'll get the answers to all 3 sets of problems. Bye-bye.